Hello everybody, welcome back. So today's mission is to talk about the derivatives of the exponential and the logarithm functions. We have the rules above you. You can look at them in your calc book. You can look at them on your formula sheet. The derivative of e to the u. Now understand in this process today, u is a function. U is not a letter. U is a function. So the derivative of e to the u will be e to the u times u prime. What you're doing is a chain rule. Now, in every video I've done, I do not go into the details of the background. I expect your teacher or your book to give you that. I'm here just to give you some practice examples. What would happen is, what I'm hoping will happen, is if I give you a problem, y equals e to the 4x, you might pause right now, try to solve it on your own, and then see how it's done. It's called practice. It's called engagement. Working with me, working together to get better at taking the derivatives of functions of exponentials. My rule is up here. My rule for log is up here. For the next few minutes, let's have fun and do some examples. So what we have here, whenever I'm doing a brand new rule, I like to really look at it. What it's saying is u is the function that's in the exponent. U is the function in the exponent. That's really what it is. I'm trying to capture it there. So according to the rule, if I want the derivative of this, I would e to the u, so write it back, e to the u times u prime. So the derivative of 4x, well, is 4, right? That's the derivative of u. And so I matched the formula. The derivative of e to anything is e to the anything times anything's derivative. And there you go. Now to clean it up, I just put the 4 in front and then be done with it. I usually don't leave the 4 at the end. I'm just working on some practice problems right now so you see how it's done. In fact, even though I said we're going to work on problems, I really want you guys to get used to cleaning it up nicely. So there's our derivative. What do you do with the derivative? Well, it depends. Do you want the marginal? There you go. This is your marginal cost if this is the cost function. This is the marginal profit if that's the profit function. What are we looking at here? This is your derivative. Do you want to maximize it? Set it equal to 0 and solve it. Do you want to find the minimum? Set it equal to 0 and solve it. What are we working with is what I need to know. I found the derivative. Do you want the rate of change? Here's the rate of change function. What are we looking for? I'm teaching you how to take the derivative. You got to understand why to take the derivative. The derivative, remember, is the slope. It's the rate of change. It's the velocity. The first derivative of distance is velocity. I don't know what you're learning. Marginals. All right, to find a max or min, it'd be in the derivative. There are many reasons we got to learn how to take the derivative efficiently. Cool. Today, though, this is not application day. This is just bust out a few examples, get loose, okay? Get low, and see how you do. So let's say we have another function. Let's say we have 4e to the 3x plus 8x. Let's say we have this function, and I need its derivative. Why? Because I want to find the marginal. The marginal is the derivative. So, all right, let's do this. Let me make sure you get used to the same symbols that you might see in econ, economics. dy dx, same thing as y prime. The derivative of y with respect to the variable x is what I'm saying there. How do I take the derivative? Well, my friends, may I call you my friends? This is that rule. This, well, the derivative of 8x should be no big deal. The derivative of 8x is 8. It's this piece is the new piece. So how do I take the derivative of 4e to the 3x? Well, the 4 is a constant, so I can leave it alone. The derivative of e to the 3x is e to the 3x times 3. How do I know that? Because the rule says the derivative of e to the u is e to the u times u prime. That's the derivative of e to the u. The derivative of e to the u is e to the u times u prime. Of course, don't forget your 8. One of the most common mistakes is get the hardcore derivative right, forget the classic derivative of 8x is 8. Now, can I clean this up a little bit? I want to make sure we do it right. I know there's some temptations to do some wrong algebra here. The correct algebra would be just to multiply the 3 and 4 to make 12e to the 3x plus 8. And there is my derivative. Once again, what you do with it, that's up to you. You want to evaluate to find a rate of change. You want to set it equal to 0 to find a max or min. Your choice. I'm teaching you how to get to the derivative first and simplify it so setting it equal to 0 is easier. All right. So that's the exponential. We'll get a little bit more difficult in a second. But let's bring in the log now, the natural log. There are other log bases. Please see advanced videos on other log bases. Here, I'm going to work on the natural log. Why? Because e and natural log are inverse functions. Might as well be able to deal with either e or ln and do them very nicely. Do them efficiently, as I call them. So natural log of 4x plus 1. Let's say I want that derivative. Good question. Good thing I have a rule. In many calc books, if you open up the first part of that calc book, you have about 1,000 formulas. All right, how do you know which ones to do? You take calc 1, you take calc 2, you take calc 3. You just keep learning about these through practice. Yeah, I'm saying practice, my friends. So there's my u. Natural log of u. Natural log of u. The derivative is 1 over u. So it is 1 over 4x plus 1. 1 over u. That's what I did. 1 over u times derivative of 4x plus 1 is 4. I followed this formula to the T. 1 over u times u prime. All right, this is u prime. I'm just matching that formula perfectly. Now, algebra, my friends, come together. Smush it together. It's 4 over 4x plus 1 is my correct simplified derivative. Remember, this is 4 over 1. So you can multiply 4 times 1, 1 times that, and you get this expression. And there's my derivative. Once again, if I want the slope at 7, when x is 7, now I can plug 7 into there, I'll get the slope at 7 when x is 7. If I want the marginal when x is 2, I'll plug 2 in, I'll get the marginal when x is 2. Now that I have the derivative, I can now dive deep into what applications use the derivative. Excellent. Again, what I'm hoping is as I write each function on the board, you guys will pause and try them out. For example, let's say we have x squared e to the 3x. So again, we put a little pause on. You try it out. Don't worry, I'll be here. I'm back. So when I see this, this is extremely important to me. When there's something in front of in front of e or in front of log, it really probably means product rule time. There really is a product there because that is the last operation the calculator would do. That is, if I plugged in a number, the last operation the calculator would do would be the product. And that's why I know it is the product rule here. There's a chance to use the product rule. In the shorthand, what I memorize is if there's a variable in front of e or a variable in front of log, I'm doing the product rule. Variable in front of e or variable in front of log, I'm doing the product rule. Variable being a function to me, x squared. So what is the product rule? Well, please go see my product rule video if you can't recall. If you're here, you've been playing around with the product rule by now. So let me lay it down for you how I do it. This is what I do. I lay down every little silly piece, u prime v, u v prime. I lay it down. I take my time. No too fast, no too furious. Where's my u? My u is the first function. My v is my second function. So there's my u and there's my v. And so what I know is right away, my u goes right in there. Pop. My v goes right into there. Bam. Now slow down and pause. Namaste. Okay. The derivative of x squared is 2x. The derivative of e to the 3x, it's up there, my friends. The derivative of e to the 3x is e to the 3x times 3. Thank you. Thank you for paying attention. Again, the derivative of an e to the u is e to the u times u prime. Can we clean this up? Yeah, a little bit. There's the word simplify. It means so much to different people. So I got to be careful based on your professor what you would like. For example, you could simply state drop the brackets for the first one because you can put those together in multiplication. This one, we will put the 3 in front, 3x squared e to the 3x. So that is your derivative. As a simplified, you need to talk to your professor. For me, I'm always thinking I gotta set this equal to 0 to solve. Now, I can set equal to 0 to solve this way or in its factored way. That is, there is one more step you could go. Again, this is perfectly legitimate answer. Just multiply these together. The 3 goes in front because that's a multiplication, and that's just kind of jumps in front. A, B, C is A, C, B. You can multiply any direction you want, commutativity. What I'm saying though is I could factor. What do this and this have in common? They both have an x and an e to the 3x. I could factor that out of both of these. I factor an x and 3x out of that, I get 2. I factor an x and e to the 3x, not sure what I said before now. If I factor an x e to the 3x, I'm left with a 2. If I factor an x e to the 3x out of there, I'm left with a 3x. This would be my factored derivative. Again, honestly, the most of the work I'm doing on this board is algebra. That's typically what stops people from doing well in calculus, is how good is their algebra skill. This is the derivative. By now, most people are catching on to how to take the derivative. This part is good old classic algebra, seeing that this term and this term have something in common and pulling it out. Why would anyone do that? Because again, the biggest thing I try to do is set this thing equal to 0 to find a maximum, right? Maximum profit, maximum velocity, maximum weight, minimum cost, minimum GDP. What are we looking for? I don't know. But we got to set that equal to 0. When I set this piece equal to 0, it's set each one of these equal to 0. That's easier than this thing up here. Setting each one of these to 0 is a little easier to do mathematically. Excellent. A few more examples. I thank you guys for being with me tonight. Or today. Not sure when you're watching the video. So again, anytime there's a function in front of e or log, it is the product rule. Of course, there are times when you might have to deal with a couple of things at once, i.e. the quotient rule, but the log is inside the quotient rule. It happens. We can make this nasty and fill up 5 boards full if you'd like. All right? Here, I'm just trying to get you started. If I get a chance, I'll write an advanced video, have some fun with some really ugly guys. So what is this? This is the quotient rule. That's really the overriding rule. How do I know? Practice, really. It just comes down to many, many years of doing this. But what I have is the fact that what's the last operation? If it was a calculator or computer, it would do the denominator, it would do the top. When you plug in, I think about plugging in for x, what would you do? The denominator, the numerator, and then divide would be the last thing. That's why the quotient rule is key to me. So in this example, I'm going to set up the quotient rule, u prime v minus u v prime all over v squared. Some of you may not know it this way. You may know it as high d low d low d high. I don't care how you learned it. We just got to take your time and do it properly. When it comes to a minus, these blocks have to be done right or you're all screwed up. So what happens is, it is u prime v. So v is the denominator. And so the v goes into both of these brackets. Right? V goes into both of those brackets, the denominator. U, the numerator, goes into this bracket. So now, if you notice, I haven't done a derivative yet. I mean, I have sort of started it. And notice I got 3 out of 5 boxes really filled. That's the thing about the quotient rule. It's not hard. You set up your 5 boxes and just know the rule. It is u prime v minus u v prime over v squared. And u is the top that I keep talking about, and v is the bottom I keep talking about. All right, so it's u prime. So I need the derivative of the natural log. Good news, it's right there. Now, it is 1 over u times u prime. But come on, guys. 1 over u times u prime, multiply those together. Really, the shortest answer here is u prime over u is what I'm going to write. And I'm going to right here attack that. U prime is the inside of the log. It's the inside of the log's derivative over the inside. That's really what I remember. It's the inside of the log's derivative, which is 2x plus 3 over the inside of the log, x squared plus 3x. So again, it's the inside of the log's derivative, 2x plus 3, over the inside of the log. That's how you take the derivative of a log. Nice. Over here, v, the derivative of v, well, that's the good old power rule, 4x cubed, and the linear rule, derivative of 8x is 8. And there we go. Clearly, I'm out of board space. I'm not so worried about simplifying at this moment. Simplifying is just more fun algebra to do. What I'm concerned with is making sure you can get to this point. All right, making sure A, you saw that it was a fraction, and B, how do you do the fraction rule? Is the derivative of the top times the bottom minus the top times the derivative of the bottom over the bottom squared. That's what it is. And so there's the bottom, there's the top, there's the bottom. I put those into place first. From there, I look at my other rules. The derivative of this, not too bad, that's there. The derivative of the natural log, that's where I had to pause and look up here. The derivative of the natural log, well, by that rule, it's u prime, the inside. And yeah, I know that says u there. I know. Slow down. This u and this u are not the same, people. Okay? This u is for the inside of this guy. There is 2 u's on this board. You know, these 2 u's. You know, these 2 u's. All right? There's a u. That's the u for that formula. So it would be u prime over u is what I wrote there. Excellent. Let's do one more, just to make sure we're good. So what do we got left? Well, we've done the e, we've done the log. Let's put a radical in the mix. All right, nothing wrong with that. Y equals radical e to the 7x plus 8 over x. Let's have some fun. That's what happens. After you learn these 2 rules, you just keep going at it. You just keep throwing things together, throwing all the rules together. The product rule, the quotient rule, the E rule, the log rule. You really got pretty much all the rules you need for Calc 1 right here. We're skipping over the trigonometry right now, but we can come back to that. So how would I take the derivative of this? Once again, got to learn proper order of operations. This, my friends, first of all, whenever you see the square root, let's go back to that old story. Whenever I see a square root, I got to think power rule, right? I got to think square root really means parentheses, a particular power. The power I'm looking for, yes, you know it, 1/2, right? Square root, 1/2 power. Flashcard time. Square root, 1/2 power. You got to nail that. Also, 8 over x. I'm going to rewrite that. Whenever I have a number in the top or the number in the bottom, I like to rewrite it. It's called algebra time. 8 over x, no way. I'm writing that as 8x to the minus 1, another power trick. 8 over x, you can bring the x up by negating the exponent. Do you have to? No. But I'm showing you what I'm doing to get my answer the way I want it to. By the way, no derivative yet. I'm just algebra time. Normally, before you take the derivative, you have to do some algebra to clean it up. And that's what I'm doing here. Radicals turn to powers. Very simple fractions turn to powers also. What do we do here? Last operation is that 1/2. Think about it. You got to do the inside, the parentheses, then the 1/2. That's the last operation. So that's the first derivative attack. I attack the 1/2. This is good review though. If I have a parentheses power, how do I take the derivative of that? That's called the chain rule. Heck, that's a chain rule, that's a chain rule, and this is a chain rule. I got all 3 chain rules I need you to know on this board. Parentheses power, chain rule. Exponential, chain rule. Log, chain rule. So what we're doing is, what's the parentheses power chain rule? It's power down, leave it inside, right? Do not touch the inside. As we've said before, over and over again, don't touch the inside. You're dealing with the power. Subtract 1 from the power, because that's the rule, right? Power down, subtract 1. Come on, guys. 1/2 minus 1. Negative 1. Half. Oopsie. 1/2 minus 1. Negative 1/2. Let's do some good algebra together. But the chain rule says, once you do the outside, come back and take the derivative of the inside, the u prime. The derivative of this inside, that's where we get fun. This is kind of like my u for the inside. I got to attack the derivative of the inside. Well, the derivative of e to the 7x, let's do it together. The derivative of e to the 7x is e to the 7x times 7. That's the derivative of e to the 7x. Is e to the 7x times 7, because the derivative of 7x is 7. Beautiful. That guy, the derivative is bring the power down, subtract 1 from the exponent. Bring the power down, that's why it's negative. Negative 8, subtract 1. Boom. There is my derivative. Yeah, I'm not cleaning that up much. There's not much to do there. It depends on what you want to do. If you want to just plug in a number, I got a calculator. I can plug it for x. If I want to set this equal to 0, I'm going to want to be careful and think about how to do that properly. But right now, this video was all about, if I see a function, can I rewrite it if need to be? This is a great example, last example, for rewriting, right? Radicals are powers. Fractions are powers too. Just got to know how to manipulate the denominator to make it a power. How did I know it was a chain rule? I can't tell you enough. Parentheses power. That's really what tipped it off. Parentheses power. So power down, leave it inside, subtract 1. Notice, left it alone. Come on, guys, say it with me. Can't touch this. Because that's what you do. Don't touch it. Now we come back, multiply, and attack the inside. Here we go. We attack the inside. The derivative of e to the 7x, the e rule. It's e to the 7x times derivative of that, which is 7. The derivative of this, well, power down, subtract 1. Boom shakalaka. Here is my derivative, my dy dx. Thank you guys for watching. I hope you like the other videos.